Today we're going to take graphing rational functions to a new level. We're going to graph other rational functions that are not the parent function, and they work a little bit differently. So it says, without using a graphing calculator, sketch each function, indicate the domain range, vertical and horizontal asymptotes, and the y-intercept of the function. Let's see if we can do that. This one says 1 over x minus 2 x plus 4. So I know that my vertical asymptotes are whatever makes the denominator equal 0. So on this one, my denominator would equal 0 at x equals 2 and x equals negative 4. So we'll pretend like there's actually a line there. 1, 2, 3. So those are my vertical asymptotes. Now we're going to learn about how to find horizontal asymptotes. In your notes, you have a page that goes through a lot of steps to find these. So let's walk through it a little bit, and we're going to spend several days in class working on these. So first of all, we have our two parent functions. And those are what we talked about last class with our transformations. So a process for graphing our functions. The first thing we're going to do is determine the horizontal asymptote. Then we're going to factor. We'll determine if there are any holes. That's a new ball game there. Then we'll determine the vertical asymptotes, and then any zeros, roots, or intercepts. So those are the steps we're going to go through every time. So you'll have lots of practice going through those. Let's talk about what happens at each step. To find your horizontal asymptotes, the numerator and denominator must be in standard form. So that means it's multiplied out. It's not in factored form. It says m is the degree of the numerator, n is the degree of the denominator. So I could have something like 3x to the 4th over 2x squared. The degree of the numerator is less than, I just skipped to a different case. Let's take this one. If the degree of the numerator is less than the degree of the denominator, case 1. So if the denominator has the bigger power, the x-axis is the horizontal asymptote. So this one we've nicknamed, we have funny nicknames for these. This one we call Bobo. If the bigger power is on the bottom, your asymptote, your horizontal asymptote is y equals 0. So bigger on bottom, y equals 0. That's what Bobo stands for. Our next one says if the degree of g of x equals the degree. So that one's going to, let's say it says 2x squared over 3x squared. Now there can be other things added on here, plus 5x minus 1, minus 8x plus 7. But we're just looking at the degree of the leading terms. So we're just looking at these, the highest power. Now, if these are not in order, you still look at the highest powers and compare those. So notice that x squared over x squared, the powers are the same. That's case 2. If the degree of g of x equals the degree of h of x, then the horizontal asymptote is determined by the ratio of the leading coefficients. This one we call, our nickname is Betsy. Bottom equals top. We divide the coefficients. So on this one, if the bottom equals the top, we just say y equals 2 over 3. We just look at the leading terms of those highest powers that are equal. So that's Bobo if the bottom bigger on the bottom. This is Betsy if the bottom equals the top. And there's only one more case. What if the biggest one is on top? Case 3, if the degree of the numerator is greater than the denominator, there is no horizontal asymptote. So that one we called bottom. Bigger on top, there's none. You can write none, you could write empty set. There is no horizontal asymptote for this one. If the bigger power is on the bottom, that means the denominator is going to get bigger very fast. And that means some number over a very big number is just going to get closer and closer to 0. If the bigger is on the top, this is just going to infinity. So it's not approaching any particular horizontal of any kind. This is something that's going to lead you into something called limits when you get to calculus. So in this will be talked about again. So that is our horizontal asymptotes. You will become a pro at Bobo, Botan, and Betsy. So let's go back to number 1. We've got a vertical asymptote. We were supposed to find the horizontal one first. So let's take a look. Is the bigger degree on the top or the bottom? Well, on the top I have 1, but on the denominator it's factored. But if I were to multiply it back together, it would be x squared. And you don't have to completely multiply it. Just know that x times x would be x squared. So this would be a bigger on bottom, a Bobo. So the bigger on bottom, your horizontal asymptote, y equals 0. So that's going to help us with our domain and our range. We've got horizontal asymptotes, vertical asymptotes, a y-intercept. Do you remember that to find the y-intercept, we always let x equal 0? So if I put a 0 in for both of those x's, let's see what happens. 0 minus 2, 0 plus 4, I get negative 1/8 for my y-intercept. So it's right down here. So if I were to sketch this graph, there's 3 sections. I already know that in the middle section, it's below the asymptote. So it's probably looking like that. It might be a little bit wider, but that's the basic idea. I need to figure out what's happening on these 2 sides. So we're going to have to plug in a couple of points just to check it. I think I know what it's doing, but let's check. So this is x equals 2. Let's plug in x equals 3. What if x equals 3? What would happen? Well, I'd have 1 over 3 minus 2 and 3 plus 4. I would have positive 1/7. So it would be up here. So this branch is doing the L thing over on that right side. Let's try the left side. What was this? Negative 4? Let's try negative 5. I'll plug that in. Negative 5 minus 2 is negative 7. And negative 5 minus or plus 4 is negative 1. So again, 1/7. So it is. So the outer 2 branches look like an even rational function, but because it's got all this other stuff going on, there's my center section. There's always something there. So to answer this question, we want a domain and a range. Your domain is going to be all real numbers except for asymptotes and holes. Y does not equal asymptotes and holes. Now, we haven't learned about holes yet, so hold on to that. The same thing happens, that is your range. Your domain is all real numbers, but x cannot equal asymptotes or holes. And again, we will learn about holes here in a little bit. So for this one, I'm going to say my domain is all real numbers, except for the things x can't be. X cannot be any asymptotes. So x cannot be 2 or negative 4. And you can write those together. When you write the equations for the asymptotes, you have to do them individually, but you can write them together when you list the restrictions. And my range can be anything except for the asymptote can't be 0. So there's a lot to do with our rational functions, and that is why we're going to practice them for several days. All right, let's look at letter B. So remember, the first thing we want to do is we want to find our horizontal asymptote. So if I look, I've got 2 over, that's x squared minus 2x minus 8. So is the bigger on the bottom, on the top, or are they equal? Well, since there's no x on the top, the denominator has the larger. So that's a bobo. Bigger on bottom, my horizontal asymptote is y equals 0. To get my next step, I need to factor. So we're going to factor our denominator here. What are factors of negative 8 that add up to positive 2? I think that's negative 4 and plus 2. So we've still not encountered wholes. That'll be a different time. But we can tell the vertical asymptotes once we've factored. Well, now I know a vertical asymptote is whatever makes the denominator equal 0. So x minus 4 would equal 0 at x equals 4. And x plus 2 would equal 0 at negative 2. So we've got 3 asymptote lines here. I have y equals 0. I have x equals 4. And I have x equals negative 2. Now they asked us to find the y-intercept. That will be helpful. To find the y-intercept, we're going to put 0 in for x. And that would be 0 minus 4 and 0 plus 2. So I think that's negative 1/8. That sounds familiar. So it's down here. So my center section, which goes below the x-axis. And now my 2 branches on the top, we can just plug something in. Let's say we plugged in 5. So f of 5 would equal 2 over 5 minus 4 and 5 plus 2. Looks like 2 over 7 here. And if I did the same thing for f of negative 3, negative 3 minus 4 is negative 7. Negative 3 plus 2 is negative 1. I get positive 2 over 7 again. So the graphs look very similar. So the numerators, the 2 branches on the sides look just like a rational even function. Oh, we didn't do domain and range. Domain, all real numbers except for asymptotes. So x cannot be 4 or negative 2. Your range, all real numbers except y cannot be 0. All right, let's do letter C. We've still not encountered any wholes, so we'll get there. So first of all, horizontal asymptote. Now this one says 1 over x squared plus 3x minus 10. So bigger on bottom, y equals 0. Now I'm going to factor. This becomes x plus 5x minus 2. And that's going to give me my vertical asymptote of x equals negative 5 and x equals positive 2. Whatever makes the denominator equal 0 after you factor it. So here's my horizontal. X equals negative 5 is out here. x equals 2 is over here. And now we need a y-intercept to help us graph. So put 0 in for x. If I put 0 in for x, I get 5 times negative 2, which is negative 1/10. So again, this one kind of does a parabola in the middle. And I think it's probably going to be up here on either side. We'll test some points just to be sure. So if I test f of 3, put a 3 in here. 3 plus 5 is 8. 3 minus 2 is 1. So I get a positive 1/8 at 3. And now let's try f of negative 6. Negative 6 plus 5 is negative 1. Negative 6 minus 2 is negative 8. And that gives me the point negative 6, 1/8. So it is above the x-axis. Domain, all real numbers, except for those asymptote lines. Your range, all real numbers, except for the asymptote line. So that's getting us off to a good start on the rational functions that are not the parent function transformations. In our next video, we'll start talking about what to do and how to tell if there are any holes.